Okay, so for today's lesson, we're going to be looking at the characteristics of a rational function. We're going to look at what asymptotes does it have, what intercepts does it have, is there a hole in the graph, and this is how we start a graphing problem. So the next couple lessons we'll get into the actual graphing, but today is just finding these characteristics because that's the first thing we'll have to do when we go to graph. So take a second, pause the video and write this down. And then I'm going to walk through it. So the vertical asymptotes, and we'll see this as we get into examples, this comes from the denominator. Because the denominator cannot equal to 0, that's where we get these vertical asymptotes where the graph will not cross. So we just look at where does the denominator equal to 0, and that's where we put the vertical asymptotes. The horizontal asymptotes, we look at the degrees of the numerator and denominator. If the degree of the numerator is less than the denominator, we're looking at a y equals 0. If they're the same degree, numerator and denominator, then it's y equals leading coefficient over leading coefficient. And then if the numerator has a higher degree, we don't have a horizontal asymptote, we will see a slant asymptote. X-intercepts, this comes from the numerator. Just a reminder, we can have single roots, and double and triple. So if it's an even degree, it's going to bounce off of the intercept, and then if it's an odd degree, it'll go through it. To get the y-intercept, we're just going to plug in 0 for x and solve, and then looking for a hole in the graph, you have to have a factor that matches in your numerator and denominator, and it cancels out. That is the x-coordinate of the hole. To find the y-coordinate, we plug the x back into our simplified equation where we've removed that factor to see what y value we get. Let's get into some examples here. So for this one, it says, identify the characteristic of each rational function. Okay, so we're going to start with vertical asymptotes. This comes from our denominator. If I were to set that equal to 0, I get x equals -4. So I have a vertical asymptote at x equals -4. Our horizontal asymptote. The degree of the numerator is 0 because it's just a constant. The degree of the denominator is 1. So higher degree in the denominator is a horizontal asymptote at y equals 0. X-intercepts. Our x-intercepts come from the numerator. And we have no x values in our numerator, therefore we have no x-intercepts. Okay, so I'm just going to say none. To find the y-intercept, we plug in 0 for x and solve for y. Well, that ends up becoming 1/2. So we have a y-intercept at 0, 1/2. We didn't have a hole in this graph because nothing canceled out. Okay, so to start this one, I am going to start by factoring that denominator. That becomes x minus 3 times x minus 3. So I will write this as x minus 3 squared. That's going to be an even vertical asymptote, and we'll see what happens with that tomorrow. So for this one, I set that factor equal to 0. I end up getting x equals 3. Again, that's an even degree, and we'll see how the pieces of the graph will be affected. Horizontal asymptote, the numerator is degree 1, the denominator is degree 2, so higher degree in the denominator is y equals 0. X-intercept, we set this equal to 0. Well, -2x equal to 0. When I divide by -2, I get x equals 0. So I have an intercept at 0, 0. I knew I had an intercept because I had an x in that numerator. You can plug in 0 for x to get your y-intercept, but if I get 0, 0 for my x-intercept, I know this has to be my y-intercept too. Okay, so for this one, this is the first equation, rational function we've seen with a hole in the graph. We have a hole in the graph because those factors are identical. So those cancel out, and if I set that factor equal to 0 and solve for x, I get 3. That's my x value of the whole. In order to find the y value, I take this rational function and I'm rewriting it with that factor removed. I'm going to plug in that x value. And solve. So I get -4/4. So my y value is -1. So I'll put that on the graph as an open circle. Moving forward, this is the equation I'm going to be using to find my intercepts and my asymptotes. So I don't go back to this original. So the vertical asymptotes come from the denominator. If I set this equal to 0 and solve, I get x equals 1. Horizontal asymptote, degree is bigger in the denominator than the numerator, so we're at y equals 0 again. X-intercepts come from my numerator. If I set that factor equal to 0, I get x at -1. I'm writing these as ordered pairs, so intercepts we always write as ordered pairs. I don't want to see x equals and y equals. Y-intercept, I'm going to plug in 0 for x and solve for y. Okay, so I get -1/1, so y-intercept at 0, -1. And there are all the important characteristics. Okay, looking at this one. I'm going to go ahead and GCF out of 2 here so I can make sure that there's not a hole in the graph. Nothing cancels out here, so we can go straight to our vertical asymptotes. I'll list out everything we need to find. Okay, vertical asymptotes come from setting the denominator equal to 0. So if I set that equal to 0 and solve, I get x equals 3. Now the degree of the numerator is 1 and the degree of the denominator is 1. So we are looking at same degree, which means it's leading coefficient over leading coefficient. So y equals 2, because that's my leading coefficient over my leading coefficient. When your horizontal asymptote is at a number other than 0, so the first 3 problems we saw were all y equals 0. If it's at a number other than 0, we have to see if it crosses the horizontal asymptote. When you graph, it's okay to cross the vertical. I'm sorry, you will never cross the vertical, but it's okay to cross the horizontal. But we don't want to cross it unless we know we can cross it. So with the other examples, when it's y equal to 0, how this is going to look is this is going to sit on the x-axis. So this horizontal asymptote is going to sit on the x-axis. So I know any place we cross this is going to be the x-intercept. So I'll know that that's where I cross that horizontal asymptote. But for this one, since it's something other than 0, I have to see if it crosses and then if so, where. So how we do this? This is y equals 2. So I'm going to set y equal to 2. And we can use either equation here. I'll go ahead and use this one right here. I'm going to cross multiply here. And I'm trying to solve for x. So when I multiply this way, I went ahead and multiplied in. These cancel out. I'm left with 2 equals -6, which is not a true statement. So you won't cross the horizontal. Because that's not a true statement. So we couldn't find an x value where it would cross. The x-intercepts, if I set this equal to 0, I get x equals -1. I write it as an ordered pair. I'm going to use this equation for my y-intercepts. So I'm setting x equal to 0. And I end up getting y equals to -2/3. Okay, there's all our important information. Okay, so for this one, I am going to start factoring. So I'm going to take out a -3. And then I'm going to factor this trinomial. This is a difference of squares I can continue to factor. Okay, I'm completely factored. So now I can see that I have a hole in this graph, so I have a factor that cancels out. If I set both of those, if I set one of those, they're the same, equal to 0, I get an x value of 1. So that's my x coordinate for the hole. I am going to rewrite this without that factor, and this is what I use moving forward. Okay? So, to find the y value for the hole, I plug in that -1 that we got right here in for x. Okay, so -3 times -2 over -3, so give me my y coordinate, I get -2. Okay, so using this one right here, my vertical asymptote is going to be at x equals 2. My horizontal asymptote, it's the same degree in the numerator as it is in the denominator. So this is going to be leading coefficient over leading coefficient. So we're looking at y equals -3. Okay, this is other than 0. So we got to see, does this graph cross that? So I set my y value equal to -3, because that's what we're saying y equals. And I'm going to go and distribute this 3 in. Okay, I'm going to cross multiply. And these cancel out again, leaving me with an untrue statement. So this doesn't cross the horizontal. Okay, x-intercepts come from the numerator. If I set that equal to 0, I get 1. So 1, 0. Y-intercept, if I plug in 0 for x, I get 3 over -2, so our y is 0, -3/2. Okay, there's all our important information. Okay, we have one more problem. Okay, for this one, we don't have a hole, no, we do have a hole in the graph. That cancels out. If I rewrite this, when we plug in -1 here, I end up getting 1 times -4 over 4, so it's at -1. Okay, there's the hole in the graph. Our vertical asymptotes. We have a vertical asymptote at x equal to 1. Horizontal, the degree of the numerator is the same as the degree of the denominator. We add those. So it's leading coefficient over leading coefficient. So we say y equals to 1. Okay, we have to check if it crosses. So I'm going to go ahead and FOIL this part out. I set y equal to 1 right there. So I get x squared minus x minus 6 when I FOIL it out. And I'm going to FOIL out the denominator too. I get x squared minus 2x plus 1. When I cross multiply, this is what I get. The x squareds cancel out. I end up getting 7 equals x. So this, we did get an x value. So this crosses at 7, 1. 7 is my x value. My y value is 1. Okay, x-intercepts come from the numerator. That's -2, 0, and 3, 0 from right here. If we plug in 0 for y, we get 0, -6.